In this video, I will focus on the data acquisition layer part. So for this project, I'm going to use two devices to show the capability of BCIs in general and how to stream the data from different devices available in the market. The first one would be the G.tec Unicorn Black device, which I have here. It's an 8 electrode configuration device with 2 reference electrodes, and this has a specific LSL connector which is available online. You can download that from GitHub, and I will place the link in the description below to view the specifications of this product and also download the SDKs related to this product. The second device that I will work with is the Emotiv Epoch Plus device. I have the device here, and as you can see, this is a 14 channel device, and the reference electrodes are just placed here. And I will use this and connect this to our program using the Cortex API, the link again of which will be placed in the description below. So you can take a look at setting up these two devices, and I would do a separate video on setting up these devices in a later series. But right now, I assume that you followed all the tutorials and the material that I've given online, and you have already connected and installed all the SDKs that are required for this project. So let's get to the code. As I said, we are going to start from scratch and build this program. So I assume that you have Python already installed in your computer, and also pip. If you're using Conda, that's also fine. These are used to install the required packages that we need. The first package that I want to install is PyLSL. But before doing that, I have created a virtual environment by having this command venv, and then automatically generates the virtual environment. I'm going to activate the created virtual environment so that I can keep my packages and dependencies conflict free across the multiple projects that I'm working on. So once it's activated, I can now install PyLSL. In my case, it's already installed. Once I have that installed, let's start with importing the required functions. These are the two functions that we will need. I will also write the device name. In my case, the device name is UN. So once I do that, I can trigger the resolve stream function. So in this case, I supply the device name as an argument to this function and creates a signal stream. And then I can use the stream inlet object and assign it to inlet signal. Once I have that, I run a loop. This loop is going to run forever, where I am going to use pull function from the inlet signal variable and store it in sample and timestamp. So the sample will contain the signals from different electrode positions, and I'm going to print the samples, and if there is a timestamp available, then I print signal stream received, and I also print the signals from here. One thing to note here is that you can also use another function called pull chunk, which will pull chunk of the data rather than pulling it as and when the signal gets generated in the device. So for specific applications, this might be more suitable. In our case, we are going to do pre-processing as soon as the signal is going to be generated. So I have some exception handling code that I've written already. So I'm just going to paste that here so that there is no memory leak once the device gets disconnected from the data stream. So now I have the device here and it is switched on. I open the Unicorn SDK that is available here, and I go to the settings page where I can find this particular device, and I pair it, and then I go to DevTools where I can initiate a Labstreaming layer for this particular device. And once I open that, I have this interface where I can close and open streams as and when required. So this particular device is 54, and I am going to open a LSL connection and then start the streaming. Now the data has started streaming from this device. What we will do now is to run this program and see if we are able to print the incoming signal from the device into the console. So Python main. So as you can see, these streams of data that is getting generated, as and when it's getting generated, we are seeing these different values and also the timestamp associated with that particular signal. So we will deep dive into how to process the signal and how to read this data in the subsequent video. In the previous video, we saw how to connect the G.tec Unicorn Black device using a Labstreaming Layer connection. In this video, I'm going to walk you through how to connect the Emotiv epoc device through the Cortex API. This is a generic overview of how to set this device up. I will also make another video where I go into the details step by step of how to set this up. I've switched on the device, and this device is a 14 channel device. I'm gonna show you how to download the required SDK. So you can find that SDK from GitHub in this link here, and I've added that in the description below as well. And you can see that there are adapters for different languages. These are different packages. I'm going to use the one in the Python folder. I'm going to clone this. Once I've cloned this, I can go ahead and browse the different files. In this case, they have different applications, which is subscribe data, record, the actual package itself, and facial expression train, and so on and so forth. But these are different applications, but one that we will be focusing on is the subscribe data.py to subscribe to the data stream. This file has a starting point here at the bottom, and you can see that there is space for you to edit the client ID and the client secret. This is something that you get once you register your product with the Emotiv website, that you can find in the account section. So if you can see, if you can navigate to account.emotiv.com, and you should be able to set this SDK up. Like I mentioned before, I will also do another detailed video of how to set this up from scratch. But for this project, I'm going to assume that you've set up your SDK and you have all your client IDs and client keys. So I have another version with me where I have updated all these keys. I'm not going to show that on video for obvious reasons. But the more important thing is there is a particular function called on new EEG data. This is the function where you will be able to tap into the data stream. So I've updated my credentials in the bottom of this page, and I'm going to just run this and show you how the data stream looks like. I'm going to run this. As you can see, the signals are being streamed in through the EEG channel, and the timestamp associated with the signal is also getting printed. Now we have two devices streaming in data. So we are going to use both these devices and show how we can potentially build a BCI based application. In the subsequent sections, we will cover the pre-processing and the processing and the visualization steps. Thanks for watching.